So, in Diploma Engineering, our first unit is integration. After this unit, we will integrate some examples with using different types of methods. As you have already seen the methods of derivative, like that, here are also different methods. Okay, so first we will see what are the contents of this unit. So first one, we have to see simple integration. In this we have to see rules of integration and integration of standard functions. In short, we'll see standard formulas and application of standard formulas in this first topic. Then second topic is integration by substitution. As we you can see on the screen. Wait a minute, I will the unit. Okay, so second topic is integration by substitution. In this method we have to know derivative as well as integration for this topic. After that, third part is integration by parts. If you remember, in first semester we have seen derivative. Okay, there is one rule for multiplication of two functions, that is product rule. Dx of u into v is equal to u dv by dx plus v into du by dx. Means first into derivative of second plus second into derivative of first. Like that, there is one rule for integration by parts. Okay. And next last topic is integration by partial fraction. This is partial fraction means what? In first semester we have already seen the partial fractions. Here we have to do integration of that part only. Means 50% process is already known to us, and we have to integrate that partial fraction. Okay, so these are four topics we have to cover in this unit. Okay. Next, introduction means integration is introduced by Greek mathematician. Integration can be used to find areas, volumes, central points, and many useful things. Now, you can say, ma'am, there are some formulas already we have, that is the area of circle, or in short, you can say we have mensuration formulas already, but these formulae are applied for the shapes who have proper what we can say proper shape. Therefore we can use mensuration problems, but the different types of shapes, for that we have to use integration. Means some I will show on this here. If we have given x-axis and y-axis, okay, and there are some points like this, okay, and we have to find area under the curve x is equal to 1 to x is equal to 2. Okay, then this one, okay, we have to find area under this curve. Okay, this uh, has no proper shape. Okay, so for this we have to find area. Okay, so for different kinds of shape, we have to find areas, volumes using integration. Okay, in mathematics, what is mean by exact integration means what? Okay, so first year or first semester you have already seen applications of derivative. In this semester we have to see in the integration. We have to see the integration. In mathematics, integration is a method of adding or summing up the parts to find the whole. Means we have to make some small parts, then add that parts and make it as integration. Okay, just we have seen we have to find area, then just make some small parts, and after that, adding all these parts, we can find the area of whole part. This is called as integration. Now it is a reverse process of differentiation. Definition of integration is, it is reverse process of differentiation, where we reduce the functions into parts. In derivative, what we have to do, that differentiation means we have to reduce the functions into parts, means we have to make parts. Okay, we have given whole part and we have to differentiate this part into small parts. Okay, after that this method is used to find summation under a vast scale. Just we have seen the example. Okay, calculation of small addition problems is an easy task which we can do manually or by using calculators as well. But for big addition problems where the limits could reach to even infinity, we have to use the integration. Okay, and integration differentiation both are play important roles in calculus or in engineering mathematics. Okay. The concept level of these topics is very high, hence it is introduced to us in engineering, not in a school. Okay. Next, what is mean by integration in general life where we have to use integration and like this. Okay. So suppose your friend gives you a wooden stick, some means one single wooden stick. He ask you to break it. Can you do so? Yes, it will be very easy for you to do so. We can easily break the one stick. Okay, but what will happen if he gives you 5 to 6 sticks to break? It is not possible, or it is not that much easy. Okay, so as the number of sticks increases, it is difficult to break them. The process of uniting the things is an integration of things. Okay, just we have seen we have to make some small parts, after that addition, this is called as integration. So similarly in mathematics too we have an integration of two functions. Integration is like one another example is drop by drop addition of water in a container. You can see here I have a diagram or figure, that addition of water in a container, this is called as integration. Okay, so let us get ourselves familiar with the concepts of integration. Okay, these are some real example or small example. And one another very interesting example is that we have know the pizza. Okay, so integration is whole pizza and the slices are differentiable functions, means this one slice is differentiable, means derivative. If we have to add all these derivatives, then we make it whole pizza, means we take the addition of these whole slices, this is called as pizza. This is very interesting example. Okay, so you can remember it easily what is mean by integration by this example, means so derivative is reverse process of finding a derivative, or integration we can say it as antiderivative. Okay, so we'll see in the next slide definition of integration. If f of x is any function and f dash x is its derivative, this process we have already seen in first semester. Okay, yeah, our given function is f of x, means any given equation, and we have to differentiate with respect to x. Then we'll write dy by dx. Remember all of you? Then dy by dx is also written as f dash of x. This is called derivative. Now, what we have to do here in integration, we have to take integration of this f dash x. Okay. First, we have to take integration of this f dash x with respect to x. As you remember, in derivative, we have to take differentiate with respect to x, then we'll write dy by dx. Here also integration is with respect to x or with respect to dx, and it is denote we have to denote this derivative by dy by dx. Remember that. Now we have to denote integration by this capital I. Okay, and symbol is elongated S. You can see here this is elongated S, means like S type but small stretchable. Okay, this is called as sign of integration, and it can be written as I is equal to integration f dash x dx is equal to. Now we have to take this function derivative of this, and if we have taken the integration of this function, then we'll get the original function, that is f of x plus c. I will show that by example. One second. Okay, one second. Means, let us see, if y is equal to f of x, means any given equation, that is function. Okay, in derivative, what we have to do, differentiate with respect to x. Differentiate with respect to x, then what we have to write, dy by dx. Derivative of y is dy by dx, and derivative of f of x is f dash of x. This is our derivative. Okay, this is our derivative. Now what we have to do in integration, we have to take integration of this function. Okay, we have to take integration of this function. Integration, this is the sign of integration, this is like s, stretchable s, f dash of x, f dash of x. Okay, now we have to write this integration is with respect to x, therefore for with respect to x we have to take dx. Okay, dx means we can say it as your this is your name f dash x, and this is your surname. Without surname you can't do anything. So that here also, for if we don't take dx, then we can't take the integration. So we have to compulsory write this dx. Okay, integration f dash x dx, as derivative of y is dy by dx, and derivative of f of x is f dash x. Now integration of f dash x is f of x. This is reverse processor. Okay, therefore the integration of this function is this function. Okay, so answer is f of x plus c. So the c means constant. In next slide we'll see what is mean by this constant, or what is the importance of this constant. Okay, so I think you will clear you are very well known about this concept. Okay, now next, this is the definition of integration, or how we can integrate given function. What is the sign and denoted by capital I. Okay, all these in this slide. Okay, next one, you can see here example. Integration means antiderivative, it is reverse process of derivative and all that. Just we have seen on this slide. Next, I will show what is the importance of this plus c. Okay, now we have just seen integration. Okay, let us see, if y is equal to for example 3x square plus 2. Okay, and we have to find derivative. Differentiate with respect to x. Differentiate with respect to x. Now derivative of y is dy by dx. All of you know derivative of y is dy by dx. Now we have to take derivative of this function. So 3 is constant, therefore it is out of derivative, into derivative of x square plus derivative of 2. Okay, so now 3 into derivative of x square. For this we have to take this formula, if you remember, derivative of x raised to n, and formula for this is n x raised to n minus 1. Okay, so derivative of x square is raised to 2 here, and power of x is decreased by 1. So 2 means it is 1, plus here you can see only constant number is there. There is no x, therefore this is not a function. This is only constant number. So for this we have to take this formula, derivative of constant, which is equal to 0. Okay, derivative of constant which is equal to 0. Now the answer will be 6x. Okay, so answer will be 6x. Now I will show some another interesting example. That is, if, one second, if I will delete this 2, okay, and instead of this 2, I will take, one second, I will take this number as 12. Okay, so now process is same. Differentiate with respect to x. Derivative of y is dy by dx. 3 is constant. Derivative of x square plus derivative of 12 here. Okay. Derivative of 12 here. Now, derivative of 12 means it is also a constant, and derivative of this one is 0. And the answer will be 6x. Now, you can see here whatever the number, 2, 12, 120, 1020 or whatever, then their derivative will be 0 and answer will be same. Therefore, this constant number will be changed. Okay, and still you have the same answer. Now, we just seen the definition of integration is, it is anti-derivative, means if you have derivative of this function is 6x, then integration of 6x will be this original function. Okay, so here maybe 120, 1020, 200, whatever. So it is not possible every time that we'll write the same number, or we don't know the number here. You can see here we have given this 6x and we have to find this function, so we don't know this constant. So in general we have to write integration is like this, now f of x plus c. So this constant will be any number, therefore we can write it as plus c. I hope you can understand this concept. If don't, we'll see in next example. Okay, now you can see here differentiation means derivative of this function will be this 1, 3x square, and answer of this will be x cube plus c. Okay, next, there are types of integration. Everywhere there are some types. Okay, so in integration there are two different types. First one indefinite and second one definite. So in indefinite integration, it is integral of any function where there is no limit for integration, means it is up to infinity. Therefore, for that some any kind of function for there is no limit, we have to add the arbitrary constant. Just we have seen on this slide that plus c. Okay, so in indefinite integration we have to add plus c in our answer. Okay, next, second type is definite integration. So it is opposite type of indefinite, means what, it has some limit. Okay, integration has some limit. There are two values for this limit in the interval of integration. One is called as lower limit and other is called as upper limit. If you remember stat, there are some class intervals. If you remember 0 to 10, 10 to 20, 20 to 30, then there is one is lower limit and second one is upper limit. Similarly, integration have lower limit as well as upper limit. As this have their own limit, therefore it does not contain any constant. Okay, so I will show it by an example. If we have integration like this, integration f dash x dx. Okay, f dash x dx, then we know that the answer of this function is f of x plus c, whatever the answer. Okay, and we have to add plus c compulsory because there is no limit. But opposite to this, integration I is equal to integration f dash x into dx from a to b. Okay, so this will be limit. This a means lower limit and this b will be upper limit. Okay, this is the limit of x. Okay, so what we have to do in this process, the answer of this can be written as, answer will be same, means here you can see answer of f dash x will be f of x. So here will be same. Answer of this f dash x will be f of x. Only difference is that we have to write this f of x in square bracket from limit x is equal to a to x is equal to b. Means what? What we have to do here, uh, whatever we have the answer, we have to put upper limit minus lower limit, and this will be the value of x. Okay, means what? F of value of x. Okay, first we have to keep this value. We have to put this value f of b, middle sign is minus, and then put lower limit f of value of x is a. So what will be the answer? We have to put upper limit minus lower limit, then we'll get some proper value. Therefore, it is called as definite integration. Okay. So this is the difference between indefinite and definite. Whatever the we have see the applications of integration, there will be a definite integration. Okay. Now, first we have to see indefinite integration. You can see example or diagram on the screen. The difference between indefinite integration and definite integration. Indefinite integration has no limit. It may be minus infinity to plus infinity. Or for this, you can see this is definite integration because this have limit a to b. Okay, you can see a to b. Just we have seen the example.